some examples on the inverse Laplace transform. You are asked to do the inverse transform of these functions, which appears to be 1 divided by s squared plus 9. In order for you to solve this, you will have to refer the tables of Laplace transform. Look at the solutions of the Laplace transform. Find the relevant structures which most closely resemble the structures given in the questions. Based on the observations, sin AT could be the solutions. Write down the formulas for the inverse transform for the Laplace, which is a divided by s squared plus a squared. You need to compare the formulas and the functions given side by side. Looking at the division region, 9 can be presented in the mode of 3 squared. So we know that a can be equals to 3. However, from the formula here, there is an a on top of the function here. With that, you have to add in the 3 into the functions. At the same time, the 3 has to be cancelled out by a constant number, so that the function here will be equals to this. Having it arranged in the proper structures here, then we can convert the inverse Laplace transform into sin 3t. Keep the constants, and that will be your final solutions. Next, you are asked to find the inverse Laplace transform here. To solve this, you will have to refer to the table of the Laplace transform. Look at the solutions. Find structures which can be used to match the questions given. We found the structure, this one could be the one matching it. Write down the formula and we will make comparison. This arrangement of the structures does not properly fit the formula here. Therefore, you will need to rewrite the function here so that it fits the structures of the formula given. First, you need to take out the 5 so that on top of the fraction here will be equals to 1. This can be done by taking out the 5 of the inverse functions, leaving 1 on top of it. Next, the formula here, the s is not to be multiplied with any numbers. What you need to do here, you have to bring out the 3 out of the inverse functions. This can be done by taking out the 1/3 out of the inverse functions, which at the end of the day, you will have to divide this with 3 so that the multiplications of this with the 3 will be equals to this. After you have rewrite the functions, it will appear like this. Now you know that 1/3 is equals to a, and the inverse functions of this can be written in the mode of e power of at, where the a is 1/3. The constant number will remain, so this will be your final outcome. Let us try this example for the inverse functions of this. Refers to the table of formula. You found this. Compare the formulas with the structures of the functions given. S power of 3 is actually s power of 2 plus 1, and you need 2 factorial on top of the fraction. 2 factorial will ultimately equals to 2. That means you have to bring out the 3 out of the inverse function here, where you do not alter the original functions. 3 multiply 2 will eventually give you 6 as well. Now you can inverse these functions in order to obtain t power of 2. The constant number will remain. This gives you this final outcome. Next, you are asked to do inverse Laplace transform for these functions. The same formulas apply. S power of 4 will be actually equals to S power of 3 plus 1, where you know that the n here should equals to 3 factorial. 3 factorial is actually 3 multiplied 2 multiplied 1. You are lacking of 2 and 1 here. Therefore, you will have to add in the multiplications of 2, and at the same time you have to divide it with 2, so that ultimately you will get the final answers to be equals to the functions given. After you have rewrite the functions, you know that inverse functions of this will give you t power of 3, and while the constants remain, so this will be your final solution.